Aloha, Richard Halverson here. This is ICS321, and today is February 5th. And so let me share my screen before I forget. Okay, so if you look at our syllabus, we finished zyBooks chapter 2 whenever we did video 4. When did we do video? Was that this week or yeah? Okay, we did that Tuesday. I think I just did section 2.8, the last one on normal forms. So today we're ready to start on zyBooks chapter 3, which is a chapter on database design. And I still don't have your thing set up for assignment 1. I better make, oh no, I do. In this class I do. Okay, yeah, this class is fine. All right, so let's go and see what is chapter 3. So let me pop over. This is the zyBooks. Put that in there. Chapter 3. All right, entity. Oh, that's right. Entity relationship diagrams. Okay, database design begins with a verbal or written requirements. Let's see what this looks like. I like the discussion. And then after that, the requirements are formalized using an entity relationship model. And then after that, after you have the entity relationship model, then you implement it in SQL. Now, one nice thing about SQL is you really can just change up the whole structure of the database, leaving the data there. If you got to move stuff around in tables and everything, it's real easy to do. You just do projections and you just do inserts from selects and all kinds of stuff. So, you know, entity relationship models are important if you're working on really big projects. But it may be that in normal size, in medium-sized projects, I mean, actually all the projects I've worked on, the most important thing is that you normalize everything, and and that's not quite as rigorous as actually creating an entity relationship model. All right, so there's a thing called an entity, and that represents a person, place, product, concept, or something. There's a relationship between entities, and then there's attributes that entities have. So here is an example of, let's see what this looks like. Passenger, there's a passenger entity and there's a booking entity. And it holds is a relationship between passenger and booking. It means a passenger holds a booking. And there's these attributes that each of these have. So got the points. All right. So that's an attribute is used in both entity relationship models and relational models. In the relational model, an attribute is a formal term for a column, and such entity relationship attributes typically become relational columns. And so the meaning is similar. So what do the following requirements become in an entity relationship model? So it's an entity. It's either an entity. All the projects become an entity. I'm just going to click this. Yes, entity. Duration of a project is an attribute. Yes, attribute. becomes a, what is the first one called? It's a relationship. So the task belongs to project becomes a relationship. See, relationship. Starting date of a task is an attribute. Yes. Okay. So an entity relationship diagram, commonly called an ER diagram, is a schematic of pictures and entities. Picture is a schematic is a picture of entities, relationships, and attributes. So this is a schematic here. And entities are drawn as rectangles in this case. Relationships are lines, and attributes appear as additional text, inside the box or next to the box or someplace. There's a whole science in what these boxes should be, what kind of arrows do the arrows have directions? Do they have little things coming out of them? That crow's feet coming out of them. We may get to that here. Okay, so here, interpreting an ER diagram, let's just see what this has to say. The ER diagram for an airline system has multiple entities and relationships, but here, but no attributes. So each entity relationship is read following the direction of a relation verb. So, yeah, okay. So, passenger makes booking. The verb includes points to the right, and the verb arrives at points down. Anyway, so a glossary, also known as a data dictionary or repository, documents additional detail in text format. For more complex databases, the designer must use a database tool or software tool designed specifically for glossaries. Okay, if it gets complicated, and in a system like this, it would definitely get complicated. And even there used to be a problem that we used to do in this class, which was like a restaurant, and you start with the order, the ticket that's got the order on it, and that goes all the way back to the inventory of spices and ingredients for meals. And so something like that definitely would require an entity relationship diagram to keep everything straight. There's a couple of things like a square, a box, does not, a rectangle does not necessarily refer to a table, but no, rectangles generally refer to tables, but there's other tables in here that are not even shown. And that depends on the relationship between these two things. Like if it's a many-to-many relationship, then this line can't be a line. There's got to be a table in there, right? It's got to be a table with a composite primary key, one for each kind of thing. So a type, there's type and instances in an entity relationship modeling. A type is a set of things, like all employees in a company. It's the entity is employee, and the relationship type is a statement about entity types. Like, there's departments and there's employees, and then there's this relationship thing. And then an attribute is a set of values, like, the addresses, salaries, for example, title, and so on. Entity relationship And attribute types usually become tables, foreign keys, and columns, respectively. Tables, foreign keys, and columns. An instance is an element. An instance is an element of a set. So a particular employee. And a relationship instance is something like where it's a statement like that. And an attribute instance is, for example, the person's salary should be pretty low. In the other textbook, the suppliers parts database, the suppliers are, suppliers is an entity type and parts is an entity type, but the SP table, the table that suppliers ship parts, that's just an that would be like an arrow in this diagram, but because of the relationship, because multiple suppliers can be shipping multiple parts, when we implement it as a database, we actually have to use a table. Okay, and so, but here we would just have an arrow, some sort of line with probably crow's feet sticking out on each side to indicate that it's many to many kind of thing. Yeah. Okay. So so that's that. So types here, you can make sure you understand what these terms mean. So database design, complex databases are developed. First, there's an analysis, then there's design, logical design, and then the physical design. Of course, it's systems analysis and design. Analysis, this sort of, breaks down what is done in the analysis steps. This is the relationship between the many to one or one, many to many or whatever, dependent and independent entities. And then in these steps, I'm not completely sure what those are. You implement the entities, implement the relationships, and then the attributes, and normalize the tables. I guess that you should probably be doing that along the way, but there can definitely be cases where you have like employees, you'll have addresses and so on in there, and as we learned from last videos, a database of names and a table of names and addresses is only in second normal form, because for it to be in third normal form, you cannot have non-key values determine other non-key values, and in a address, names and addresses, you have the zip code determines the state. The state depends on the zip code. So anyway, so yes, you should do this at the end. Sometimes maybe sparingly, I don't know. Okay, so here we're gonna step 2, discovery. This is where you when you're creating a database, you interview people, you find out all the different entities and the relationships between them and the attributes of the entities and so on. Let's see what this does for me. So here we have we fly. Let's see. So this would be like you're interviewing somebody, and you have a description here that would probably come out of an interview, and so the database designers, they go on and they're gonna develop this database for an airline, I suppose, and they don't know everything. They have an idea because you know, most people have taken an airplane flight, but not everybody has done that. So you have this discussion and you're able to identify these entities here. We fly many flights in and out of airports. We keep track of airport codes and addresses because we often ship airline parts direct to the airport. Each flight has up to 200 passengers, depending on the size of the aircraft. So we're talking all these kind of entities, okay? And an entity would be an airplane, but the attributes, you know, can vary greatly depending on the size of the airplane and so on. When a traveler makes a booking, we have to save the total cost because prices change all the time. Also, we also record the passenger name, credit card and mileage plan number, and so on. So let's see what happens when we click on this. So we have these entities. See, as you read this, you're identifying all these entities, discovering the entities, and some more. Travelers, passenger, and then addresses, airport codes and addresses, and credit cards, parts. Wow. I wonder why that's shaded. Actually, our database doesn't track parts. Okay, great. Okay, makes sense. Okay, the next is discovering the relationships. We fly many. Okay, so let's see how this works. What time is it? 11:49. We arrive at an airport, departs from an airport. A passenger makes a booking. So it should be arrows, not arrows. A flight has a passenger. A flight includes bookings. We don't track the shipment of parts. Is that it? What about the other ones? Okay, anyway, and then there's this many flights, same discovering, those were attributes. These are relationships, and these are attributes down here. Okay, so let's see what that looks like. Discovering the attributes. Well, there's airport codes, so that each airport has an airport code, passenger has a passenger name. There's a total cost for the booking, and there is also a mileage plan number. Okay. Which verb is a relationship? Have? I don't know. No. We have a record. Taken? Taken suggests, the student takes course, all right, sure. Which noun is an attribute? I would say, title? Yes. All right. Title of the person. Got it. Okay. Entity names are singular noun, employee, rather employees. So that's why some database, that's why they like to name tables. A table of employees, they like to have it be singular. That's why. The best names are commonly used and easily understood by the database user. Relationship names have have the form entity verb entity, such as something contains something. When the related entities are obvious in the ER diagrams or in formal conversation, verb is sufficient, and entity names can be omitted. The verb should be active rather than passive. Okay, it manages rather than is managed by. Somebody manages a department. Occasionally, the same verb relates different entity pairs. Order contains line item, or division contains department. Attribute names have the form entity qualifier type, such as so this would be like the names of columns. All right. So that's just naming conventions. That's great. Now, synonyms and descriptions. So a glossary contains complete descriptions of entities, relationships, and attributes. Okay, so we're talking about pretty big systems here. In MySQL, there's a comment field, for variables and so on. I guess that probably would suffice for me. So let's see what this one looks like. Here we're synonyms and descriptions. Traveler is a synonym of passenger. Synonyms, I see what this does. Anyone with a booking is a passenger. Airline employees fly free, but they still occupy seats and have to book tickets. People like flight attendants don't occupy regular seats, so we don't consider them passengers. So when flight attendants are on duty, then they're not considered passengers, but if a flight attendant is off duty and flying as a simple airline employee, then it's considered a booking. Very good. No, synonyms help, but okay, anyway, so you should, okay, so the database design, the first step of the analysis phase is discovery. As we just saw, as discovery proceeds, the designer draws an ER diagram, determines standard attribute types, documents names, synonyms, and descriptions in the glossary. So the designer is, keeping track of this glossary, creating it as they go along. Identify entity relationships and diagrams. So first you do that, which we described. Draw the ER diagram. List the document. Okay, so so here we have a challenge activity. Let's see what it is. Our company manufactures appliances. Each model of appliance has a description and a model number. Each model of appliance uses many kinds of parts. Each part has a unique number. For each part, we track the quantity we have on hand and the number we expect to be delivered with the next shipment of the part. What are we supposed to do here now? Select the entities. Maybe this and this. Select the relationships. Part, inventory. This should be inventory, I presume. Inventory. Okay, are all these relationships? I don't know. Select attributes of the entities. Yeah. No, this is a shipment. Is a shipment an entity? Maybe it is, in which case this would be. I wonder if they're all supposed to be, I'm going to say, I think this is wrong. Incorrect is highlighted. Each incorrect answer is highlighted. Okay, wow. So part is used in appliance model. So expected part, appliance model are the entities. Part number, part quantity, model number, and description are the selected attributes. And part is used in is the only, well, that makes sense then. Okay, so part is the only entity. I mean, part and appliance models are the only entities. I'm gonna take a screenshot of this. Okay, let's understand. Okay, first of all, let me take a screenshot of this. I want to take a screenshot of this. Okay, I've got that. Put that over here. Now let's see why we got what we got wrong. In this scenario, describes attributes and relationships for nouns, appliance model, and part. Okay. Oh, I see. Okay, so this is a parts. Okay, this is not a store that sells stuff, that ships appliances. This is a store this is a parts, a manufacturer of appliances. So there are these appliance models. I can see that there are appliance models, and then there are appliance models, and along with that, and then there's parts, and there's a relationship between appliance models and parts. Part is used in appliance model, and so shipping has nothing to do with anything really. So the selected attributes are part number is an attribute of the part. Part quantity is the number of parts on hand. For each part, we track the quantity we have on hand. Okay, so that's why parts quantity is there. Okay, appliance is not an entity because it would refer to an individual appliance, but the scenario describes appliance models, not individual appliances. Okay, great. Shipment is not an entity because nothing is said about it. Okay. Neither expected shipment date or part name are mentioned, so they're not attributes. Oh, they have to be mentioned. Okay. Okay, this isn't just, we aren't just using our understanding of a part would have a name. We have to pay attention to the description up here. Okay, so okay, so let's try this again. Okay, here we are. So we publish a newsletter with statistics about baseball teams. For each team, we know the name of the city where the team plays and the name of the league to which it belongs. We track who plays for which teams. Each player has a name, a height, and a weight, and a batting average. So it looks like we've got teams and players. So select the entities. I'm going to say team and player. Select the relationship. Player plays for team. Select attributes of the entities. Each player has a height. Each player has a weight. That's not here. Each player has a batting average. That's not here. League name, don't talk about that. Team record. For each team, we know the name of the city where the team plays and the name of the league to which it belongs. Okay, so league name. Oh, name of the city where the team plays is an attribute of the team. I don't see anything about player salary here, do you? I do not. Team record? I don't see anything about team record here either. Player name. Player's got a name, so that. All right, so let's see what this is. That's much better. All right, that was a tough one. Let's see what the next one is. 1204. State maintains a database of colleges. Each college has a name and an identification code. Each college has a number of departments. Each department has a name, an address, and a phone number of its main office. Each faculty member works for one or more departments. Database includes the name and the rank of each faculty member. Okay, it sounds like state maintains a database of colleges. Okay, so there's colleges, there's faculty members. Wait a minute. Yes, that's right. Rank, no. Department. Each department has a name and address. So each department has name. Colleges have departments and not office. Okay. College has department. No. No. Faculty member works in department. Yes. All right. This is my guess. Hey. All right. Okay. Very good. What's next? Cardinality. How far are we going here? I'm going to step back here and see where we're going here. Cardinality and geez, super type. Oh, there we go. How about that? Wow. Wait a second. What's normalization? Didn't we? Oh, I don't recall talking about denormalization. Okay. Let me go back. How is this different than this one? Okay, this just talks about all the normal forms. Okay. All right, so let's keep moving here. You know, I may have to have a second class next semester, next week on this. By the way, you know, these are turning into. Thank you, Peter, for coming. These are just turning into, for all my classes, they're more just times that I'm going to record the lecture, rather than times to hold class, because you know, I've presented I've recorded a couple of sessions this week where no one came, which is fine. I'm used to. I mean, most of the time when I record these things, you know, I'm not recording them before an audience. I'm just recording them to post on YouTube for people to see. But I cheat. I have these be class periods, because then it's just a matter of holding a class, holding a 1 hour class, and there can be these dead, useless periods that have nothing to do with teaching anything, like right now, I'm kind of rambling. Whereas if I were strictly creating videos to be posted for lessons, I couldn't have any of this. They should be 15 minutes long, no longer, and all that. But every now and then, students are very happy that I have these sessions because they can ask questions and so on. But anyway, so let's keep moving here. We are in Cardinality. And in the past, this is the first semester that I'm using this textbook to the depth, and actually lecturing on it. And in the past, everything in this chapter used to be just one assignment, and it's pretty important stuff, and it really is a good way of looking at designing and documenting databases. So I'm glad we're spending more time in it. It's tough to find this kind of stuff in databases. It's tough to find a database textbook that's got everything that you want without it being highly mathematical, throwing in a bunch of mathematical stuff, and which I could never understand. But I mean, I could never understand why in an undergraduate database class we had these textbooks that had so much math in them. And it's like you cover the first couple sections of about 5 chapters out of 25, and the book costs $200, and anyway, I think those days are going away now because of all of this automation, grading automation. All right, so cardinality refers to the maxima and minima relationships of the attributes. It has to do with, like, a relationship maximum is the greatest number of instances one entity can relate to a single instance of another entity, and you'll see what this means in a moment. A relationship has 2 maxima, one for each of the related entities, one for each side. Maxima is usually specified as one or many, or as one or m in ER diagrams. One or many. One or many. A department can have many employees. An employee works in only one department, though. You see, so many to one. So see that here, but okay. So here's how they are expressing it. Different ways of expressing it. I like crow's feet. Crow's feet entity relationship. I'll do this later. I'll show you that later. Occasionally, relationship maximum is a number greater than 1. Each employee has at most 3 telephone numbers in the database, and each telephone number belongs to at most 1 person. This employee has telephone maxima are 1, 3. Usually you would just take care of that by having 3 fields in the data in the table. So anyway, so here we go. An airline can schedule many flights. Let's see how this works. So each flight departs from at most 1 airport. Each flight departs from at most 1 airport. So you put the 1 there. And each airport has many flights, so you put the M here. So each airport has many flights, but a flight can only depart from 1 airport. Arrives at and departs from have the same maxima. Arrives at and departs, so a flight, a flight departs from only 1 airport, a flight arrives at only 1 airport. Makes sense. Each airline schedules many flights. While multiple airlines share the same flights. Each flight can be scheduled by many airlines. Yes, when multiple airlines share the same flights, each flight can be scheduled by many airlines. Yes. Okay, that's, it doesn't happen that often, I guess, but, airlines, more than one airline can be like sponsoring a single flight, so it's, I guess that's what this means. All right, so that's interesting. Are we done? Let's finish. Each airport resides at most one official address. Each address has at most one airport. Yeah, that makes sense. All right. Determine the maxima for each of these relationships. Correct answer may depend on business rules. So if a student takes course, that would be one to many. No, many to many. Sorry, many to many. Because a student takes many courses, and a course can have many students. City is capital of state. 1-to-1? Yes. Person has passport. Each person just has one passport, but a person can hold that's right. A person can hold passports from several countries. Each passport belongs to one person. Each passport belongs to one person, and a person can have many passports. So one to many, person to passport. One person, many passports. Person has mailing address. So I guess it's 1-to-1. No, several people, yes, of course. Several people can have the same mailing address. So many persons, one mailing address. So it should be this one. Okay. Person owns vehicle. A person can own many vehicles, and can many people own a vehicle? Well, I think my wife would argue if I say I just own the vehicle. So I'm going to put many to many, but they might mean one person, many vehicles. Let's see. I think it's this one. A person can own many vehicles, and in most states, a vehicle can have many registered owners. Okay. All right. Relationship minimum. Okay, it's 0 or 1. A relationship minimum is the least number of instances that can relate to a single entity or another entity. A relationship has 2 minima, one for each of the related entities. So in this particular book, we put the minima, I guess, in parentheses. Okay, so employee works in department relationship. A department may have no employees. Each employee must be assigned to a department, though. So the employee works in department. Minima are 0 and 1, or I guess 0, 1, yeah, 0, 1. Okay, so employee department 0, 1. It means the department can have 0 employees, but employee has to have at least one employee has to have at least one department. In fact, it's at most one department. Can an employee be in more than one department? I don't know. Occasionally, relationship minimum is number greater than 1. 2 forms of identification are required for customers, and each identification document belongs to only one customer. All right. So you can look at this. Determine the minima for each relationship. Correct answer may depend on business rules. Person marries person. I don't know what the answer is. I'm going to try this. Oh, yeah, because a person, since a person can be unmarried, person marries person is 0 to 0. Yeah, sure. A person can be married to more than one person, though. Oh, okay, we're talking about minimums. Person has passport. So person can have many passport. Minimum 0. Oh, a passport has to have a person. Passport has to have a person, but a person does not have to have a passport, right? Yes. Every passport must belong to a person. Flight arrives at airport. Many flights. Minimum. Let's see, an airport doesn't have to have any flights, but a flight has to have an airport. Oh, assuming the database does not track new or inactive, all airports have an incoming flight. Well, sure. So it's 1, 1. Okay. Attribute maximum. Entities have an explicit relationship with their attributes called entity as attribute. This relationship, like any other, has a maxima and a minima. Singular, plural, unique. Oh, these are for unique attributes are not the same as singular attributes. A full name is singular because each employee has one full name, but a full name is not unique because, you can have more than one. More than one employee can have the same name. ER diagrams, entity and attribute maxima appear as either M or 1, separated by a dash, followed by the attribute name. Occasionally, attribute maxima are specified as a number greater than 1. Parent name attribute of a person entity has a maximum of 2, since each person has had at most 2 since each person has at most 2 biological parents. Sure, got that. Okay. So employee number, it's sort of a one, unique and singular. Passport number, unique and plural. Singular is just 1. Okay. Anyway, the only way you're going to be tested on this stuff is by completing these participation activities and any challenge activities that happen to be here. Here's one here. Challenge activities are a little bit more difficult because you can't just, the answer is not obvious. You got to keep on trying to figure it out. But anyway, so let's see what we have here. Okay, here's a match the term to the database requirement. Okay, we track at most 1 contact number for each student. Telephone number is at most. Let's see, is it singular? Yes, okay, it's not 100%. Students can major in several subjects. Major subject name is plural. Students sometimes do not provide a telephone number. All students must have an official email address. Yeah. All right. Database design. Determine the relationship maxima and minima. Determine the attribute maxima and minima. determine the cardinality. Okay, so yeah, I can see how you have to, this is one way of doing it. You determine all these things, and then the actual design of the database becomes much more much easier because all the stuff's defined already. Cardinality refers to, I think it's false. ER diagrams maximum are drawn for relation. No, that's probably yes. The analysis phase cardinality is always determined after discovery is complete. I don't know. I'm going to say false. All right, here's a nice challenge activity. Let's see how this one works. Determine the maxima for the relationship. The correct answer may depend on business rules. Assume typical situations. Okay, so the first one. Book is checked out by person. A book can be checked out by, a book does not have to, a book, book can be many books can be checked out by many books, one person. I'm going to say it's this one. Oh no, that's right. Yes, many to one. A book is checked out by only one person. A person may check out any number of books. Okay, so it's many to one. All right, what's next? League has team. Determine the minimum. A league has to have at least 2 teams, I guess. A team has to have a league, and a league has to have a team. I don't know. This is right. Oh, it does. It's right. All right, well, you can continue with that. It's 1225. Let me see what 3-4 looks like. Okay, independent. Okay, yeah, this is getting pretty important. Okay, so I'm going to end it here. Next week, I'm going to have two video taping sessions because we got to get through this chapter 3. And so we did not finish chapter 3. Oh, look, we are continuing chapter 3 next week. So I'm going to see, we may still have two sessions. We'll see. All right, are there any questions? Peter, how you doing?
Good. Sorry, I couldn't figure out to unmute.
Yeah.
Yeah.
I wasn't
no
sure.
questions.
You know, sometimes students, you know, they leave, you know, so, I mean, they
yeah, no,
leave it. So I didn't want to embarrass you. So I didn't want to ask you, hey, Peter, you there? You know, but no.
Yeah, I'm here.
Okay. So
I have to admit though, next week though, I'm going to be traveling to the mainland. I have some family issues I got to take care of, so I may or may not be able to attend classes, but I will try to be here for everyone.
Okay. Yep. All right. Well, that's great. I'll be recording them anyway. I used to wonder if I should wait till somebody shows up to start recording, but I don't do that anymore. I just, start. People pop in and out, and so that's fine. All right. Well, great. Well, thank you for coming today, and
Sure.
have fun on the mainland. Stay safe.
Okay, we'll do. It's not for fun. It's more for to take care of some family issues. But anyways, it's my first time going to Montana, so I guess in a way I'm looking forward to it.
Oh, wow. Yeah, I've been to Montana once in my life too. I had a relative that lived there. Okay, well, good. Well, have fun in Montana. Kind of conservative up there, but that's fine. It's gonna be cold too. It's still cold time.
So it'll only be a couple of days. I'll be gone Monday and Tuesday. I'll be back Wednesday. So if you do a class on Monday or Tuesday, I won't see you, but I'll see you later in the week.
Okay, great. Thank you.
All right. Thanks so much. Appreciate it.